Hi, welcome to the pre-calculus lecture series. And in this video, we're going to start the section 7.2. And for this chapter, it's called the Analytical Geometry. So basically, we're going to talk about a lot of the formulas derived from the trig functions. So for the previous video, we covered some basic identities like reciprocal, Pythagorean, and the cofunction, those things. Okay, so today we're going to talk about another very important set of the formula is the addition and the subtraction formulas here. Okay, so let's go ahead and go to our worksheets and let's try to get it started, okay? So the first things here, we're going to talk about addition and the subtraction formulas here. And those ones here is pretty useful for you try to find some special angle and how to use subtraction and addition formulas here. Okay, so for first set is for the sines, all right? So if you have a sine, okay, so if you add the two angles here, like s plus t, so when you sine s plus t, so the formula will be here, will be the sine t cosine t. Sine s cosine t. So will be sine cosine here. Let me erase this, make sure I write it. So this will be sine s cosine t plus cosine s sine t. Okay? Or if you have in here the sine s minus t, then this one will be almost exactly the same. So it will be the sine s cosine t minus cosine s cosine t here, okay? So in here, the key things here is like if this is a plus, and then this is a plus. If this is a minus, then this is a minus. So sine is sine, cosine, cosine, sine. Okay, and then the next set is here is a cosine here. So if I have a cosine s plus t here, cosine, it will be cosine, cosine, and sine, sine. So this will be the cosine s, cosine t, plus, I'm sorry, not a plus. So here, this will be minus here. So it's a minus sine s, sine t. Okay, then the same way, if you have a cosine, s minus t, it will be cosine, cosine. So it will be cosine s, cosine t, then plus sine s, sine t here. So this is a little bit opposite like sine, right? So in here, if you have a plus, then here you have a minus. So if you have a minus here, you have a plus here, okay? So now the next things here, it will be tangents here, right? So the tangent, so this is s plus t here. So the tangent s plus t, it will be equal to, here is a tangent s plus tangent t. Then this is 1 minus tangent s. Okay, so this will be 1 minus tangent s, tangent t here. Now if you have a tangent s minus t, so this will be equal to the tangent s minus tangent t, and this is 1 plus tangent s, tangent t. So a quick way to remember this is the same thing here. This is a plus, then here this is plus. And this is a minus, here is a minus. Then here is the opposite. So if this is a plus, then this is a minus, this is a minus, and then the bottom is a plus. So those are the three sets of the formula. So for the secant, cosecant, and the cotangent, the way you do it, you find the sine, cosine, and the tangent first. Then you use reciprocal to find its values here. Okay, let's take a look at where we can use it. Okay, so for example, like for the first ones here is a cosine 75 degrees, right? In a unit circle, remember in a unit circle, we have like a few key points here, right? So we have a what? We have a here, 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 right? So we have this is the square root of the 3/2 to the to the 1/2, and then this is the square root of the 2/2, square root of the 2/2. Then this is 1/2 over the square root of the 3/2, right? So we only have those few specific values. So this is like we said, this is 30 degrees or pi/6. This is 45 degrees or pi/4, or this is 60 degrees is pi/3. See here. So now the 75 is not one of these special angles here. So if I want to find the value of cosine 75, so what I can do is here. So I say, okay, cosine 75. I know the cosine 75, I can change to some of those special angles. So I can say this is a cosine what? Cosine 45 plus what? Plus cosine 30. Right? So 45 plus cosine 30. So now I can use a cosine plus, it's a cosine cosines, right? So will be cosine 45, I use the cosine formula. So it's a cosine cosine, so cosine 45, cosine 30. Because this is a plus, so I have a minus. So I have a minus sine 45, sine 30. Now, how nice, right? So this is a degree. So I change to what? I change to the special angle. So I know the cosine 45 by the unit circle, this is what? Square root of the 2/2. What is the cosine 30? The cosine 30 is the square root of the 3/2, right? And then sine 45 is what? Square root of the 2/2. What is the sine 30? Is 1/2, right? So now I can say, okay, so this is a square root of 2/2 times square root of 3/2. So this is square root of the 6/2 minus, right? So this is, I'm sorry, 4, right? Minus 2 times 2 is 4, the square root of the 2. So the answer here, this is the square root of the 6 minus the square root of the 2. That is what we get the answer. So like in here, we don't have, we don't have the special angle, but I can change that here, all right? Okay, so now in here, the cosine, let's take a look at the other one here. This is a cosine pi/12. So pi/12 really is what? Pi/12 is 15 degrees, right? We don't have this on the, the unit circle. So I can change the 15 degrees. I can say, what are the two special angles I have? I can say it's 45 degrees minus what? 30 degrees, correct? Okay, so now I can change these ones here. So I can say this is the cosine. 45 is pi/4 minus 30 is what? Pi/what? Pi/6. Now in here, I have a cosine, right? So now cosine, so I say cosine pi/4, cosine pi/6. Here's a minus, so I have a what? I have a plus, sine. So sine pi/4, sine pi/6. Now I change everything to the unit circle. So what is the cosine square root of pi/4? Is the square root of the 2/2. And what is the cosine pi/6 is the square root of the 3/2. Then plus sine pi/4 is what? Pi/4 is square root of the 2/2. Sine pi/6 is what? 1/2. So I will have 4 square root of the 6 plus 4 square root of the 2. So this will give me 4 square root of the 6 plus square root of the 2. All right, okay. So now let's take a look at the second ones here. So they said, okay, try to find the exact value. Whoa, the 20 and the 40, Those not the special angle we know, but then if you take a look, this is the one is the sine cosine plus cosine sine. So what is the formula I can use here? So if you put this ones here, you say that this is my angle S, this is my angle T. So this is my angle S, this is my angle T. So this one is become to sine S cosine T plus cosine S sine T. So go back to the original formula. So sine cosine is what? Sine cosine, cosine sine is what is sine? S plus T's, right? Okay, so now I can see here. So this one will be the sine 20 degrees plus the 40 degrees, right? So I know this is the sine what? 60 degree. So what is the sine 60 degrees here? Is the square root of the 3/2 here. Okay, so that's why you can use the sum and the subtraction formula to find the sum angles, even they are not those special angle in the unit circles here. Okay, so let's take a look at number 3 here. They say, hey, verify the 1 plus tangent, 1 minus tangent equal to the tangent pi over 4 over x here. So I say, okay, let's start here, right? Okay, so this is the tangent theta plus s plus t here. So let's see here, this is a tangent pi over 4 plus x. So what is the formula tell us? It will be tangent pi over 4, right, plus tangent x. Then because here's a plus, so bottom is minus. So it's 1 minus tangent pi over 4 tangent x here. Then I know the tangent pi over 4 is what? Is a special angle, so it's 1. So from the unit circle, so tangent pi over 4, this is 1. So now I can say this is the 1 plus tangent x, 1 minus tangent x. So this is equal to my left-hand side, right? So I proved it, right? Okay. All right. So now, okay, so let's take a look. This will become a little bit harder now. So let's take a look at example number 4 here. So the example number 4, they said write the, the right sine cosine negative x tangent negative y as an algebraic expression of x and y here. Okay, so now let's see here, right? So let's take a look at this one first. Arctangent x here. Remember we did it in the previous section. So for this problem here, the arctangent, so we say, let's draw triangle first, right? So this is my angle theta. Okay, so angle theta, cosine, arccosine is what? Is adjacent over hypotenuse. So it's x. So this is x over 1. So adjacent over hypotenuse. So this is the x. Now what is my hypotenuse? So what is my hypotenuse? Is 1. Then by the Pythagorean theorem, what is this side? Is 1 minus x squared. Correct? All right, so this is angle theta, right? So let me mark it. This is the angle theta. All right, so now I'm taking a look at the tangent, arctangent y. Okay, so arctangent y, so it's another triangle. So instead of theta, I call it phi, right? So arctangent is what? Arctangent is opposite over adjacent. So y is equal to y over 1, right? So I know this is the y, this is the 1. Correct? Then what is my hypotenuse? My hypotenuse will be 1 plus what? Y squares, right? Okay, so this is my angle phi here, right? So that's why we need to, so let me see here. So this will be my angle phi, right? So this is angle phi. And so then this is what is my angle theta here, right? So let me try to color coding that. So now I know this one's here, the sine, cosine, arccosine x plus arccotangent y. So I can write this as because cosine, arccosine becomes theta. So it's theta plus arctangent is what become phi here, right? So become phi, so become sine theta plus phi. Okay, so now I can use the addition formula, right? So this will be the sine cosine. So it's a sine theta cosine phi. Here's a plus, so it's a plus cosine theta cosine phi, right? Okay, so be careful where you use cosine, where you use sines, right? So let me color coding that. The one with the theta, I use greens here, right? So sine theta is here, right? So sine theta is related to the angle theta. Sine is opposite of hypotenuse. So this one here is 1 minus x squared. So cosine theta is here, also related to the theta. Cosine is adjacent over hypotenuse. So this is x, correct? Okay, now I'm looking for the angle phi. Phi is here. So cosine phi, cosine is what? Is adjacent over hypotenuse, right? So this one's here is adjacent over hypotenuse. Is 1 over 1 plus what? Y squared. Then the sine phi still related to these angles, right? So sine is the opposite over hypotenuse. So what is this one here is y over 1 plus y squared, right? So you see my color coding, the green one is related to the angle theta, and the blue one is related to the angle phi here. So now I can combine it. So this one's here, the first term will be the 1 minus x squared over 1 plus y squared plus x times y, right? So plus x times y, the y plus y squared. Ha, it's good, the common denominator. So I have here, this is will be 1 plus y squared. So this is the 1 minus x squared plus xy, see here, right? So this one here is a pretty good problem because basically you need to know, combine the knowledge you learned before. How do you get the arc cosine and find the angle? How do you draw the right triangle? Find the side, right? And then finally you use the addition formulas here. Okay, let's try to do one more this type of the problems here. Okay, so they said evaluate the sine theta plus phi, where the sine theta is equal to the 12 over 13. Okay, so let's see here the theta, let's color coding that. The theta is in the quadrant number 2. And then the phi is in the 3/4. So phi is in the quadrant number 3 here. So let's be very careful, right? Okay, so now let's take a look. How do I find it? All right. Okay, so first still, let's draw a triangle here. Okay, so this is my angle theta. Okay, so let's try to color coding that. So this is my angle theta. The sine theta is the opposite over adjacent, right? So it's 12 over 13, right? Then by Pythagorean theory, we know this is a triple pair. So it's 12, 13. What is here is a 5, right? Okay, now let's take a look at phi and other triangles here. Okay, so this is my angle phi here. All right, so this is angle phi. The phi is 3 over 4. So tangent is opposite of adjacent. So this is 3 over 4. So 3, 4, what is the Pythagorean theory? The hypotenuse is 5 here, right? Okay, so now this is in quadrant 3, right? So this is in the quadrant 1, 2, 3. This is the quadrant what? Quadrant 2 here. All right, let's be careful. Okay, so now they say find the sine theta plus phi. Oh, you see here, now you say, oh, this is the sine cosine addition formula. So you will say sine theta cosine phi. plus what? Cosine theta sine what? Sine phi is here. Okay, so now let me color coding that we're doing the theta here. The sine theta already give you, so this is 12 over 13. Okay, so now I'm looking for the cosine theta with respect to the theta. Cosine is adjacent over the hypotenuse, so it's 5 over 13 here. But this is the second quadrant. So cosine is what? It's negative on the second quadrant. So I need to make sure I have a negative signs here. All right. And then now I'm looking the angle phi here. Cosine phi, all right, cosine phi is here, right? Cosine is what? Is adjacent over hypotenuse, right? Because this is a phi is in the third quadrant. So what happened to the cosine value? Has to be a negative. So I have to have a negative values here, correct? All right. Okay, so now let's take a look here. Sine phi, sine is here. So what is the sine phi? Is 3 over what? 3 over 5. But also because this is the quadrant number 3, then what is the sine in the quadrant number 3? It's negative also. So I need to add a negative. Okay, so now I can find the values here, right? So this is a 13 times 5 is 65. So this is a negative what? 48 plus 65 is negative what? 15. So when you add them together, so what are you going to have? You're going to, oh, no, here, I'm sorry, negative, negative. What I have here, I have a positive here, right? So it's negative 48 plus positive 14, the negative, negative. So what I have here is negative 33 over 65. Okay. Okay, so that's it. That is how do we use the, the addition and the subtraction formulas. And now we're going to talk about one very special formulas here is the sum of the sine and cosine. So all these formula, we have a sine, cosine, cosine, sine, or sine, sine, cosine, cosine. How about if you have in here, right? So if I have, I said A, sine x plus b cosine x here. So how do I do these ones here? They both have the angle x here. So we know, so this formula is quite useful. So we say, what is here? We say here, all right? So we can say this one is equal to, okay, is some constants times the sine, then the x plus 5 here. Okay, I'm not going to prove it. I'm just kind of write out here as a part of the formula. And so if you just have a sine plus cosine, you can kind of expand that to a sine x plus 5. So what is the value? So k here is equal to a squared plus b squares here, okay? And what is the phi here? The phi, you need to satisfy both conditions. So the cosine phi will be equal to the a over a squared plus b squared, and sine phi need to equal to the b, okay? So it's a b a squared plus b squared, okay? So phi needs to satisfy both conditions, right? So then you need to decide where is the phi were located here. Okay, let's take a look at these examples here. So let's say express the 3 sine x plus 4 cosine x in the form of a k sine x plus 5. Okay, so first things here, let's try to do this. Let's mark the value. So what is 3? 3, this is my a's, right? Okay, what is 4? 4 is my what? Is my b's, right? Okay, so after that, now I say, okay, based on this formula, k is equal to the a squared plus b squared. So it will be 9 plus 16. So what is a k? K is 5. It's good, right? Okay, so now let's see here. So let's say now they need to satisfy this, right? So I know the sine phi has to be equal to, okay, so I did not write here, and here I need to be careful. So this is the sine phi, right? Okay, so the sine phi is going to be equal to the b's, right? So what is the b here? B is 4, right? Square roots of here, this is a 5. And the cosine phi is equal to a, so it's 3 over what? 3 over what? 3 over 5 here, right? Because this one is positive, this one is positive. So both sine phi and cosine phi positive. So I know the phi is in which quadrant? The phi going to be in the quadrant number 1 here. All right. So now you use the calculator. So now you can say the phi is equal to the sine, arcsine, what? 4/5, right? So your calculator will give you something very close to 53.1 degrees. Okay, so the now, so finally your answer, so this will be 5 sine x plus 53.1 degrees. Okay, so of course, if in here you have a positive and negative, then you need to be careful and see where is your phi will be, right? So which quadrant, then you can decide what is your phi, what is the angle phi. Okay, so that's it. So this is the video for this section. So the most important formula we talk about is the summation and the subtractions, right? So the one we talk about is the 3. So the be careful about those signs, right? So we have a sine, cosine, cosine, sine. That is sine, s plus t, right? So cosine is a cosine, cosine, sine, sine, right? So you need to make sure the positive and negative is here. So that's it. And like you can see, we can use this addition and the subtraction formula to find the angles, which is not in the my special unit circle, special angles, like 75 degrees. I can break the 75 degrees as 30 and 45, right? And then both 30 and 45 are special angles, and then I can find it. All right. Okay, that's it. And hope that you, you have a pretty good understanding about how to use addition and subtraction formulas. All right, that's it. And nice talk to you. And looking forward, we are going to talk about our next section is also is probably the most important formula for the trig when you go into the calculus. You talk about the half angle, double angles. All right. All right, that's it. Nice to talk to you and looking forward to talk to you soon. Okay, bye.